Hello, I'm going to start with the segment bisector or midpoint. I preferred to leave a blank sheet rather than have the graph on it as if I were having a normal sheet of paper. So I would start with an arbitrary length segment. And then I would grab the compass tool and create a circle that has a radius of AB but is centered at A, and then do the same again, the radius of AB but centered at B. And then I notice that they intersect above and below the segment. So I will grab the intersection of both of those and then use my line segment tool to connect them. I can also use the intersect tool to pinpoint the intersection between A and B. And since it's a bisector, we know that the length from A to E in this instance should be the same length as E to B. So to verify, I can use the distance tool to measure the distance from A to E. And the distance from E to B, and they should be the same. I could also utilize the midpoint tool after it's all said and done to verify that I did in fact find the midpoint of these 2 points by selecting A and B, and it does in fact match. When I look at the graph itself here, the algebra tools, they are the exact same point. Our next one is the angle bisector. So I'm going to start off by using my segment tool to create an arbitrary acute angle, angle ABC. I'm then going to use the circle tool with the center through a point, just so that I can create a circle that expands and cuts through both AB and BC. D can go off to the side, it doesn't matter. I just need to make sure that it cuts through AB and BC, such that I can grab the intersection between the circle with each part of AB and BC. I now need to use the compass tool so that my radius is exactly the length from E to F, where I'm going to center the circle at E and then create another circle that has a radius E to F but centered at F. I see now that my circles that I just created have an intersection off to the right hand side here, so I'm going to place a point at that intersection. And then I'm going to hide the circles to kind of clean this up a little bit so it's easier to see what we're working with. I then can connect using my segment tool B to G, and I should have created an angle bisector so that it cuts the original angle exactly in half. And we can check that by grabbing the angle measurement tool and checking A, B, G, and G, B, C, moving the angles a bit so we can verify that they are in fact the same measurement. The next one I'm going to attempt is the perpendicular bisector when I'm given a point on the line. So I'm going to start again with an arbitrary line segment, and we'll just call it AB. And then I'm going to choose to hide these points. I don't really need them, so I'm just going to make them just a little smaller just so they're kind of out of my way so I don't get distracted. and leave them there if you decide you want to, I suppose. I also could hide the name F if you want to. And then I'm going to put a random point on the line anywhere I desire. We're going to call that C. I'm then going to use the circle tool to create an arbitrary sized circle with center at C, and I'm just going to choose a radius of 2. It doesn't really matter, but I'm going to just choose a radius of 2. I see that my circle intersects the line I had created, or the segment I had created, so I'm going to place the 2 points at those intersections. I'm then going to create a circle that has a radius that's slightly larger than the distance from the segment DC. So maybe we'll do 3, just so it's a little larger, but centered at D. And then do the same with E over here using the exact same radius. At which point I notice that the intersection of these larger circles are directly above and below C. So I can use my intersect tool to create that intersection, which I'm now able to use my segment tool to connect those 2 points. I am going to hide my circles to make things a little easier to see. And then to verify, I'm going to use my angle measurement tool to measure FCE to verify that it is in fact a 90-degree angle, such that we have made a perpendicular line at a given point C. In my next one, we're going to do creating a perpendicular line given a point not on the line. So I'm going to start with a line segment. It doesn't matter how long it is. Maybe I'll just make it a little bit longer. That's kind of short. And then I'm just going to grab a point and put it somewhere not on that line. I'm then going to use the circle tool to create a circle with a center through a specific point. It doesn't matter where. I just want to make this circle large enough so that it intersects through my line segment. I now see that my circle intersects in 2 locations through my segment, and so I'm going to plot those 2 intersections. I now am going to create a circle with a specific radius, but it has to be just somewhat larger than more than halfway through the segment EF. So maybe I'll choose like 3. That looks like slightly larger. And I'm going to do the same with F with the center at F here, also the exact same size. Now I see that my circles intersect one another. So I'm going to use my intersect tool and plot the intersection on the lowest point. I now can create this line segment connecting my point with G. And I'm also going to plot my intersection where C connects my segment as well. I'm going to use that in a second. But then I'm going to hide some of the things that I don't quite need that are kind of in the way to kind of clean this up a little bit so we can see things a little bit more clearly. I'm going to double check that the measure of angle CHB is in fact 90 degrees. And I want to make sure, here we are, and we have created a 90-degree angle or a perpendicular angle given a point not on a line. My next goal is to show you how to create parallel lines. I chose to create a parallel line through a given point, not on the line, as that was the example that was given in the video lessons and then the Euclid book that we read. So I'm going to start with creating an arbitrary line or segment, And then I'm also going to put C, my point not on the line, somewhere above here. Then I'm going to connect A and C together using a ray for now. I'm then going to use my circle tool to create a circle with a specific radius, because I'm going to need to use that radius again. With my center at A, I'm going to say 2, because I want to make sure that my circle goes through AC and AB. Not too far, but just enough so that I can see that they intersect somewhere. So I'm going to mark those 2 intersections where my circle meets AC and my circle meets AB. At this point, I'm going to create the same circle with the same radius at point C. And my radius I used with the center at C, my radius was 2. I then see that my new circle intersects also through AC, and I'm going to intersect that point at the furthest point away. Now, using my compass tool, I'm going to grab the circle which has the radius of the distance between D and E. But yet I'm going to place that circle with a center at F. I now see that my new circle intersects the circle with the center at C. I'm going to grab that intersection, and now that's my point G. I now have a line that can connect C and G together. So I'm going to use my line tool and connect C and G together. I'm going to hide my circles to clean this up a little bit. And I'm going to hide my ray here as well. There we are. And I should see that these 2 are parallel to one another, and I can verify this using the parallel line tool, where I'm going to connect A and B, and I would like that parallel to C. And it does in fact appear that they are parallel to one another. Okay, bear with me with creating the rectangle. I felt like I had a lot of steps to this, and I had to make some notes and make sure I was following them correctly. Considering we could only use parallel lines and perpendicular lines, and we weren't allowed to use the shortcut tools, I felt that mine got a little messy at times, so I try to clean it up the best as possible as I go throughout. And maybe there is a simpler way, but this was the way that made the most sense to me. So please bear with me, maybe put me on 2 times speed, perhaps. But I'm going to start with a given line segment, given a specific length, and I'm going to do a specific length of 5. I'm then going to put a point not on that line over here somewhere, and I'm going to use the same steps that I did to create a parallel line. So I'll make a ray through AC. I'm going to use my circle tool with a given radius, let's say 2, with my center at A. Grab those intersections, create another circle with the same radius of 2, but my center at C. I see the intersection with circle C furthest from the angle itself, so point F. And then I'm going to create a new circle with my compass tool using the radius from D to E, but my center at F, such that now my circle with center at F and my circle with center at C intersect over here at the right. So I'm going to grab my intersect tool. Now I can create a line that intersects C and G together. Right. These 2 should be now parallel. AB should be parallel with CG at this point. I am going to hide the circles and rays that don't mean anything to us right now, just to kind of clean it up a little bit. Okay. The next step I'm going to do is using line CG, I'm going to drop a perpendicular down to AB. So I'm going to treat A as it was the point that's not on the line, and think of CG as my line itself. So I'm going to utilize the circle tool to create a circle at A that expands past line CG. Then I'm going to use my intersect tools to intersect CG with the circle I just created. I'm then going to use another circle with the center at J, and I want to make sure that my circles, if I can pretend a line that drops down from A to CG, go a little over halfway between the midpoint of the two intersections that I just created. A circle with a radius. So at K, perhaps I'll try a radius of 2, not quite big enough, so I'm just going to undo that. Maybe do 2.5. That looks good. And then also over here at J with the same size. Okay. Now I see that these intersections appear to be lined up directly with A. So I am going to use my intersect tool to construct the intersection at the furthest point away, at which point I can create my segment that goes from A to L down here. But I specifically would like my segment to intersect with line CG. So I'm also going to grab that intersection here, because that's the one that's most important to me. To clean this up a little bit, I am going to get rid of some of these lines, and I'm going to re-put the segment simply from A to M, because I don't need the segment to go all the way if I'm just creating a rectangle. And then eliminate the circles that aren't very helpful. Eliminate the points that again aren't very helpful, and just clogging up space. Okay, and I can also verify that this did create a perpendicular line. I'm going to use my angle feature and do M, A, B. And I see that it is 90 degrees. I also need to do the same thing, creating a perpendicular from line CG to a point not on the line, specifically B. So I'm going to follow the exact same steps again, where I'm going to create a circle with center at B and expanding that circle far enough so it crosses through CG, line CG. Grabbing those intersections, looks like O and P here. From O and P, I'm going to create a circle with a specific radius with center at O, and I want to make sure that my circle expands, its radius expands a little over halfway between OP. So maybe I'll try 2 for now. Not quite. I'll undo that. Maybe I'll try 3. It looks a little halfway, but maybe just to make sure I'll do 3.5. I suppose I could have used just like the generic circle tool and then used the compass to build the exact same size, but I thought this was just as easy to kind of think about the size and spatial aspect of them. And P, I need to make the circle the same exact size with also a radius of 3.5 with its center at P. And now I do see that they certainly do intersect very obviously. And I'm going to grade that intersection at the furthest point away. Now I'm going to connect my line segment B and Q, and I'm also going to use the intersect tool with CG because that's the specific one that we are most interested in, and then make the segment, let's get rid of some stuff, and then I'll make the segment from B to R. So at this point we're going to get rid of some of our circles, again, cleaning things up because it's kind of a hot mess here. And then I can connect with my line segment B to R. And again, I want to make sure, yes, the length of this is the same, but I want to make sure that this is also a 90-degree angle, which it should be, of course, but RBA is 90 degrees. I can also verify that AMG is 90 degrees. I suppose AMR, and then of course MRB down here is 90 degrees. And I have created a rectangle where if I wanted to clean this up a little bit more, we certainly could. If I got rid of H, the point C, the point G, I could create my segment M to R and have my full rectangle here.